Hello my YouTube friends and welcome to my channel. Today I'm going to look at and discuss the sequence control of motor.
Every single day I'm gonna make something great. That's my way.
What is sequence control? Sequence control simply means running or operating motors in a particular sequence, and then they can start in a certain pattern and stop in a certain pattern. So you've got a pattern. So like we are saying, um, so one motor may run and then the other motor starts after a preset time, or several motors may be running and they stop in a particular sequence of time. And this is applied usually in industry, in machine operations, high industrial applications where you've automated the operations, like in the mines, in hydraulic presses, um, in various operating systems. So we have what we call a manual control, where we can start the motors in a sequence by using a controller, a human being who goes to press the start button. Or we can also have an automatic control where using an example that I'll show. We can use programmable logic controllers, which are PLCs, or we can use timers to run certain operations. Okay, so here's a question. A control must be designed to operate three motors in the following manner. So what this is requesting for you, the student, is to design a circuit, for instance, that has three motors that must run in succession, starting from motor 1 to 3. Motor 2 will start only if motor 1 is running, and motor 3 can only start if motor 2 is running. When the stop button is pressed, all the motors must stop. When one of the overloads trip, all the motors must trip. So here is a power circuit. We've got three motors. Sorry about that. We've got three motors. So this is our motor 1, our motor 2, and motor 3. And this is the power circuit. So you can take it if you want as red, yellow, blue. This is a three-phase supply. So three-phase supply. And then you've got motor 1 powered, motor 2 and motor 3. This is the overload. So you've got the contactor. This is what we call the motor starter. The contactor, and so we call this a motor starter. Okay, so it will be more clearly visible here. So this is what is happening, and so now we look at the control circuit. When we come to the control circuit design of this is as follows. This is a manual design, a manual control. We want to see how we can run these motors manually by pressing the push buttons. So what you see here is a control circuit that has been designed. So the principle of designing a control circuit is to first we use the two lines, which may be line 1 and line 2, or it may be a live and a neutral. And in between here, we design the circuit, because as we know, the way we design a circuit, so here's line 1, line 2, is that power flows from left to right. So you're having power coming in from there to there. And the control circuit also may have a control transformer here, which is stepping down the voltage from the supply voltage to the control voltage, which is usually between 110 volts to 120 volts in between here. Okay, so then let's look at this circuit. So the design has been done. We want to run these 3 motors in succession. So if you look at this, the way the power is running, once the start button 1 is pushed, so once this makes connection, current is going to flow through this line, energizing contactor 1, and contactor 1, once energized, is going to close its auxiliary contact 1M, and then once this is let go, power will continue flowing through like so. So here you have, once this returns to its normal operating, then power will continue flowing in the circuit like so, and continues further out. Okay, so motor 1 has started running, but if you see this connection that is here, this implies that motor 2 now has access to power, because power is now flowing through this connection, also able to flow up to there and up to there. So we can now continue to run motor 2. So motor 2 has got power access there. So we can now run this power by pressing this push button 2. Once this is pushed, it makes contact there. Power is going to flow, energize contactor coil for motor 2, which will close this, and power will continue flowing through like so and returning. So then what will happen now is that this will return to its normal status, and you have power flowing through this holding contact to M. And the same procedure now, push button number 3 has got access through this line and through this line. So power is able to flow up to here because this is open, and up to here because this is open. Once we push this button, current will flow and energize the coil for contactor number 3, which is going to close this contact, the auxiliary contact, and power will be able to flow up to the coil. And this is going to return to its original status, which is open, but power will continue flowing because this is closed, and returns like so. Okay, so this is one of the ways that we can do the circuit. And so this is the second method that we could use. We tap from after the stop button, and then we can tap all the motors, but we engage in what we call an electrical interlock, which is here and there. So this interlock is going to depend on motor 1 being energized. That's when it will close, and then we're able to power motor 2. In a similar way, when motor 2 is energized, then this will close, and we're able to get power to energize motor 3, contactor 3. Okay, so these are the 2 design methods that you can use. Now, we can also have what we call an automated control process, where we just push the push button once, and thereafter it continues to engage the other motors using the timers, like we have seen here. We've got timer 1 and timer 2. So what will happen in this circuit is that once this push button is pushed, current will flow through to contactor 1 for motor 1, which when energized is going to close that contact, and at the same time the timer relay is going to be energized, and this timer relay is going to begin to count. So this is a time delay timer in closing or in activation. Time delay in activation. So what is going to happen is after 5 minutes, like in the setup that is showing here, 5 minutes, you have this contact closing. Once it closes, this motor gets energized, and at the same time, the timer for the second motor begins to time. And once this timer finishes counting 5 minutes, this timer contact closes, bringing in motor 3. These times depend on applications. It's usually in seconds. In most cases, it's usually in seconds that we can bring in other motors. You're looking at long conveyor belts where it will take a long time for a product to reach the other conveyors to start. So after 5 minutes, that's when the other conveyors start. So you're looking at time saving as well and energy saving by setting up these systems. Okay, so this is one of the ways we can automate a system and use automatic control. So that is what we call as sequential control. So we're looking at designing circuits that can operate manually or automatically and to solve a certain solution. For instance, in here, we have a design problem which says you've got 3-line motors to be started and stopped from a single push button. Each is to have its individual cross the line starter, and then there is to be a small time delay of 30 seconds between the starts of the machines as the machines accelerate in sequence. Also, the tripping of the overload relay on one starter must stop the particular motor and not affect the other two. Design a control circuit to fulfill the given specifications. So what we are looking at now is the circuit design. So we are saying once we press the stop button, all the motors must stop, and then we have to have each motor coming on after 40 seconds. Now here it's telling us that once the individual overload triggers or trips, motor 2 is going to stop. So motor 2 alone will stop. If overload 3 stops, only motor 3 is going to stop. So this is the task that was at hand to design here. So we have a situation where if we press the start button, motor 1 gets energized and the timer starts to time. Okay, once the timer finishes to time, 40 seconds later, it causes this contact, which brings in motor 2, and motor 2 closes its holding on contact. So this is a backup holding on contact in case there's a fault with the holding on contact for the timer, for the timing relay. And then the moment motor 2 is energized, it energizes also the coil for the timer 2, which after say 40 seconds will close this contact and energize contactor 3, which will close this contact, and all the motors are running in sequence. Now we look at a different problem, which is stated here that it is desired to start 2-line start motors from a single start-stop station simultaneously under the following conditions: depressing the stop button or tripping of the overload relay on motor number 1 shall stop that motor only, and 4 seconds later, motor number 2 is to be stopped automatically. The tripping of the overload relay on starter number 2 shall stop both motors immediately. You are to design a control circuit to fulfill the given specifications, and we can see this in the design that I drew here. Okay, so let's look at this circuit now. The way it operates is that once we press the start button, motor 1 is going to get energized. At the same time, this timer relay is going to get energized, and instantly is going to close this contact. This is a time delay contact. Okay, we write it as a time delay contact. So it's going to automatically close that, bring on motor 2. So these will close at the same time and they'll act as holding on contacts. Okay, so the moment we press the stop button here, once we cut the circuit, what is going to happen is that motor 1 is going to get de-energized instantly. Then the timer will only begin to count. So it will count 4 seconds later. That's when it's going to de-energize motor number 2. And that is what the question is saying. So if we look at the other conditions, tripping of the overload on relay number 2 shall stop both motors immediately. So when we come to this, if this relay trips, if this relay stops to operate, then motor number 2 will de-energize, opening this contactor and this contact, and motor number 1 will also get de-energized. So this circuit design fulfills the design objectives that were set. So we look at a design problem number 3. It is desired to control two motors in the following manner. Depressing the start button at the start-stop station will start motor number 1. This motor will continue to run until it is stopped either by pressing of the stop button or by the tripping of its overload relay. Then, when motor number 1 stops, motor number 2 is to start, and after running for 1 minute, will stop. You have to design a control for the specifications as said. When this motor is running, this instantly opens this contact and this remains closed. Okay, so the moment we stop this button, the moment this motor is stopped, once we stop, this is going to return to its closed status instantly. This is the time delay in opening. So this will remain closed and will allow current to continue flowing, and it will start the motor number 2, which will start running, but this will be timing to open. After 1 minute, it will open and this motor will stop running. So that is the design of the circuit. So to go through it again, once we press the start button, motor 1 starts running, closes that contact. Motor 1 is energized. The contactor 1 is energized. Timer relay opens this one. So this opens up. This is closed. It's a time delay in opening. It's already closed. So motor number 2 does not energize at all. When we push the start the stop button, then motor 1 gets de-energized, opens here. The timing relay retains this contact to its original state, which is closed, and finds this already closed, and for that reason motor contactor number 2 gets energized. While this is energized, this is a time delay in opening. It will count after 1 minute or 60 seconds, is going to open, and that motor will stop running. Design problem number 4, probably our last. Design a control circuit for 5 motor conveyor system that will operate in accordance with the following specifications. Each motor is to have its own across the line starter and its own start-stop station. It shall be necessary to start motors 1 to 5 in numerical sequence. This shall be done by pressing the start buttons in succession, and only one motor at a time shall start when the start button is pressed. If the pressing of the stop button or the tripping of the overload relay of motor number 5 stops the latter, meaning it stops only motor number 5, it shall be the only motor to stop. The stopping of motor number 1 shall stop all motors. The stopping of any motor by the pressing of the stop button or the tripping of its overload relay shall stop the particular motor in addition all higher numbered motors. Okay, so this is the design. Okay, this is the design. So we are saying that motor number 2 will only run when motor number 1 is running. So if we press this button, we have current flowing through like so, energizing motor number 1, which closes there, and therefore motor number 2 has access to power. So power is coming through like so and comes through up to here and up to there. Of course, it's going through motor number 1 like so. So now we have the chance to press or to start motor number 2 because motor number 1 is running. So when we push that button, current flows, energizes motor number 2, which closes its holding on contact, and current continues to flow through it like so, and continues up to the start and here up to the holding on contact until we push this button. When we push this button, current flows, energizes contactor 3. Contactor 3 closes its contact and current continues to flow through it like so. When we press, then again current flows up to the start and up to 4M. We are able to push this button now because there's access of current here. When we push this button, current flows, energizes 4M, which closes its holding on contact, and this allows current to flow through like so, retains, and then also flows through up to the start and up to the holding on contact. When we press the contact for motor number 5, current flows through, energizes the coil closes its holding on contact, and current continues to flow in the circuit like so. So this is how the circuit is running. Now, what happens if the overload of motor number 4 trips? What is going to happen if the overload of motor number 4 trips is that motor number 4, if this opens, so this has tripped, it has opened, this coil gets de-energized, okay? Current cannot flow through, so it can't pass there because this is open. It can't also pass there because this is open. Therefore, motor number 5 can't get energized. It's also going to get de-energized. So motor number 5 will not receive current. So what will happen is these two motors, motor 4 and 5, will stop. And this is the same principle that is going to work if any of these two also stops. If number 2 stops, then 3, 4, and 5 motors are not going to run. If number 3 stops, then 4, 5 are not going to run. If number 4 stops, then 4 and 5 are not going to run. So this is the way this circuit is operating. And if we press the stop button here, if we press the stop button, then all the motors stop running. If the overload of motor 1 trips, then all the motors in succession stop running. This is how this circuit has been designed. So thank you for your time. Enjoy the rest of your day. My dear friends, thank you for watching this channel. Subscribe to the channel for more. Thank you. Have a good day.